right. Thanks for listening while we take that short break here at Revolution Radio, freedomslips.com. And now we're going to get back to your host.
There is no record option, but ladies and gentlemen, welcome to another episode of Cosmic Catastrophe on Revolution Radio. I am your host, Diamond, from the Oppenheimer Ranch Project, and joining me is my lovely partner, Leah Shaper. I can't hear you.
Oops, it might help if I turn my mic on.
There you go.
Very strange that there's no record option all of a sudden.
Well, it's going to go offline in just 4 days here.
I know, it just seems weird that they would remove a feature right before they take the whole application offline.
Yeah. So I am using a screen grabber right now, so we are recording the show.
Cool.
But I was panicking because I figured that out in the last 3 seconds.
I was looking for the record to go on, and I did the same thing. I was looking for the record button because I'm like, oh, I'll hit it if you don't, and then it's not there.
So hopefully I don't stop the screen grabber during the show.
Don't do that.
It's so complicated right now. All right, we've got a great show for you, those listening out on Revolution Radio. The big question that we had in our last show that we ended with is, why do we have meteor showers the same time every year? And we're going to dive a little deeper into that. Are they dangerous? And in fact, they may be the biggest threat to humanity that we know of. Other than, let's say, the sun, a super flare from the sun.
Sure.
I think that's top two. All right, so I'm going to share the screen.
Great image.
Yeah, what we're looking at for those listening on the radio is the Eta Aquarid meteor shower, which is coming up here in early May. And so let's just dive into it. What is a meteor shower? A meteor shower, this is kind of interesting. In doing research for this, the fact that it's only been 200 years since we even started to try to understand what these are.
Right.
Clearly, humanity has been witnessing them for millennia.
Yes. And warning about them for millennia as well.
But only recently did we just try to figure out what's going on. It's funny, as early as 200 years ago, they used to think that meteor showers were atmospheric phenomenon, meaning something to do with weather.
Oh, interesting.
Yeah. So these days, a meteor shower is a celestial event in which a number of meteors are observed to radiate or originate from one point in the night sky, which is referred to as the radiant. These meteors are caused by streams of cosmic debris called meteoroids entering Earth's atmosphere at extremely high speeds, and these objects are on parallel trajectories, which is why you get that radiant effect, meaning they all emerge from it appears to be emerging from a single point in the night sky, and they move out in all directions like spokes on a wheel. So this would be similar to looking down a railroad track and seeing the railroad tracks touch in the distance.
Right.
So that's the radiant. But all of these objects are traveling on parallel trajectories.
Right. It's just from our perspective, they look like they're coming from a central point and radiating outwards.
Exactly. Now, most people don't understand that most meteors are smaller than a grain of sand. And almost all of them disintegrate and never hit the Earth's surface. But obviously, larger chunks, which we would then refer to as asteroids, some of those reach the surface. So very intense or unusual meteor showers are known as meteor outbursts or meteor storms. These produce 1,000 meteors an hour, and the most notable of these is the Leonids, which, ironically enough, was one of the first meteor showers to be scientifically explained. So let's talk about the historic developments here. So it seems that the first meteor shower recorded was in the Timbuktu manuscripts in 1583. But in the modern era, the first great meteor storm was the Leonids of November 1833. So it must have been a meteor outburst, which got the attention of scientists. One estimate for the 1833 Leonid outburst is a peak rate of over 100,000 meteors per hour. So that would have been crazy.
Mm-hmm.
All coming from one radiant. I mean, what would you think is going on?
Right.
But another study done as the storm abated estimated more than 200,000 meteors during the 9 hours of the storm. So that's a little less, but still pretty amazing.
Mm-hmm.
This is what's interesting. The entire region of North America, east of the Rocky Mountains, was able to see this, but they weren't able to see it anywhere else, including Europe.
Right.
So you had to be at the right place at the right time to see one of these outbursts.
Right.
American Dennis Olmsted explained the event most accurately. After spending the last weeks of 1833 collecting information, he presented his findings in January 1834 to the American Journal of Science and Arts, blah, blah, blah. He noted the shower was of short duration and was not seen in Europe, and that the meteors radiated from a point in the constellation of Leo. He speculated the meteors had originated from a cloud of particles in space. And that is the first account of actually what a meteor shower is.
Mm-hmm. At least in modern times, anyway.
Yes. Work continued, yet coming to understand the annual nature of showers, though the occurrences of storms perplexed researchers. So they were still perplexed on why they came back regularly.
Mm-hmm. Mm-hmm.
The actual nature of meteors is still debated during the 19th centuries. And here's what I referred to earlier. Meteors were conceived as an atmospheric phenomenon by many scientists. So that's kind of interesting.
I mean, in a way, they weren't wrong, right? In the sense that we're talking about debris that is interacting with our atmosphere, but it's not...
the flexure point of the space, exactly.
Right, right.
All right, so let's get to the answer of the question, why do we have meteor showers the same time every year? Well, in order to understand that, you have to understand the origin of these meteoroid streams.
Mm-hmm.
Now, the problem with that is that modern science still goes back to Fred Whipple's 1951 description of a comet as a dirty snowball. And their explanation of how the meteoroid streams come to be is through the sublimation of ice and then the release of particles of dust being held together by ice in the dirty snowballs.
Mm-hmm.
So there's a big problem there.
Yeah.
So here we go. A meteor shower results from an interaction between a planet such as Earth and a stream of debris from a comet or occasionally an asteroid. That is funny because they just gave themselves away there. They don't understand that comets and asteroids are the same thing.
Yep.
And then they add all the gobbledygook. Comets can produce debris by water vapor drag. But that's not what's going on. And we explained this last week. What's going on is that these asteroids or comets are discharging. And we have photographic evidence of it, which we're showing right now.
Right.
So it's through electrical scouring that these micrometeorites are blast off the surface of the rock.
Mm-hmm. Mm-hmm.
Yeah. And before we go any further, let's dive a little deeper. An amazing article written by David McCandless in 2005 explains it very well. It says, dissident scientists advocating a controversial theory of the universe are having a field day in the wake of NASA's Deep Impact Comet collision earlier this month. Scientists promoting the electric universe model say their predictions for the comet mission appear to have been more accurate than NASA's. The electric universe theorists collected at the thunderbolts.info believe that electricity when factored properly into astrophysics, plays a greater role in the cosmos than the standard gravitational model, which says electric forces are insignificant on a cosmic scale. Now, proponents of the electric universe model say they can explain many of the bizarre phenomenon and mysteries in cosmology, from a swath of anomalies seen in the solar system to unusual surface features on Mars, Jupiter's moon, Titan. The theory can also sweep away the need for theoretical dark matter and dark energy. And comets are the cornerstone of the model. Why? Because it's visible proof of the legitimacy of the theory as they traverse eccentric orbits around the sun. Now, according to the model, which is the electric comet model, comets are not inert balls of ice and rocky dust particles aggregated into dirty ice balls. And this is all supposedly happening at the formation of the solar system. And this is what the standard comet theory holds. That as our solar system formed, remnant ice and dust formed into comets, which there is no evidence whatsoever for that. So instead, comets are solid asteroid-like rocks which contain almost no ice that are negatively charged with electricity. Their motion through the positively charged solar wind triggers electrical discharges. These, not vaporized ice, produce the characteristic comet glow and tail and subsequent meteoroid streams. Yes. So,
I mean,
go ahead.
this is 20 years ago, you know, and we, as you just showed, we have we keep saying this. We have photographs of comets showing that they're rock, not ice. It's very clear, and that you can visually see that they are electrically discharging. And this was made very clear 20 years ago, and yet the narrative is still that these are dirty ice balls.
And areas where the most scouring on these comets is where the most discharge is occurring, where we can visually see that occurring here, which creates these barbell effects.
Right.
And I didn't bring it up, but NASA just went and took a picture of another object in close proximity, and it is shaped like a barbell, and they explained it as two objects being fused together.
Which, as we've discussed on this show, is so statistically unlikely, and it's like doesn't even make sense at all. But yet there's all of these barbell-shaped objects all over, and we're supposed to believe that they all got like stuck together. I mean,
okay, so what happens is, how do we get a meteoroid stream that becomes regular and periodic, a meteoroid stream that arrives at Earth? What you have is comets discharging continuously throughout their orbit. Now, we can show you the pictures, but it becomes even more insane when I bring up this image. This is a comet that has broken apart now in two pieces, and you can literally see the debris stream from corona to corona here.
This is interesting, too, because last week when we talked about Comet Biela, there was a historical observation that had been made after Biela broke up.
Yeah.
That there was like a jet between two pieces of what were Biela, and this is the same thing.
So either it has a little plasma in it because all of the dust particles are charged, and or both. Because what we know about our solar system is that when you go out in a dark sky region, the sky is glowing, and that's due to dust. That's due to these particles in the atmosphere. It's due to all of this cometary dust in all of these ovals all over our solar system. So when you're looking out along the plane of our solar system, you can see this dust. And so, did I explain that thoroughly enough, how the meteoroid stream, each time these comets swing by the sun is when most of the discharge occurs and most of the debris. It's interesting because some of the dust We've seen comets that have ion tails out the front and a dust tail out the back with an ion tail out the back. So up to 3 tails or more. And sometimes the front ion tail pushes dust forward. So there's dust being, these micrometeorites being pushed in the front of the comet as well as in the back of the comet. And their speeds vary. So some of them are slow and the comet can catch up with the dust. Does that make sense?
Yeah, I mean, well, all of it is a function, right?
Eventually, after 1, 2, 3 passes, it starts to become more homogeneous. Yeah. So go ahead.
Just the basic idea here being simply that as a comet breaks apart because of its electrical interactions with other bodies, especially the sun, or it could be Jupiter, right? That was the hypothesis behind Biela's breakup, is that somewhere in the vicinity of Jupiter that it broke up. But as that happens over time, the debris stream gets more and more stretched out. But this takes a very long time, or it can, right? Like, for example, the Taurid meteor stream still has very concentrated areas, but nonetheless, there is still debris within the whole orbit, which was once a cometary orbit, and then our orbit, Earth's orbit, crosses the path of that twice a year, simply because you have two, an elliptical thing and 2 elliptical paths crossing each other.
Well, the Taurids are unique as far as meteor streams because most meteor streams we only pass through them once a year, 99%. The Taurids are unique because it's not that way. We go through it twice, which is strong
Wouldn't that have to
evidence.
Be true for any,
go ahead.
Any meteor stream that has an orbit like that intersects with our orbit? Wouldn't we have to cross twice?
No, because these comets are not following our planet, the plane of the ecliptic of planets.
Okay,
they come in at an inclined angle.
Right.
So the ellipse only passes through the plane of the planetary plane once. The Taurids is on our plane, which is huge evidence that it's the most dangerous stream. It goes between Jupiter and Earth. And so Jupiter can perturb the stream because it's the biggest, most gravitationally significant planet. And it goes out right near Jupiter. And there are some associated objects that they call minor planetoids that follow the same path. So those could be some of the giant objects that didn't hit us during the Younger Dryas impacts.
Yes.
And they still may come back.
Well, I don't want to get too off topic here. Do you mind if we talk more about the Taurids?
We'll get into that in the second half. Let's just talk about meteor streams first, all right?
Yeah, okay, fair enough.
Okay, so here's the Eta Aquarids. Now, what's weird, and I don't know why they did this, is I think that they should have named the meteor streams after the parent bodies. And what I mean is, like, Swift-Tuttle is the parent body for the Perseids.
Right.
So why aren't they called the Swift-Tuttles?
I think the reason is purely historical and the order of discovery, right?
Like, and it goes back to the Leonids. They noticed it emanating from Leo, so they named it that.
Right. So we first observed meteor streams and we started naming them for where they were coming from.
Yes.
And it was only later that we recognized that all of these meteor streams are the remnants of some comet body.
Yeah.
At least that's what we think.
Yeah.
And obviously you can see from this chart that we haven't identified
Right.
all of the comets that are responsible for meteor streams. And even in fact, like we talk about the Taurids in relationship to Comet Encke, but in reality, Comet Encke is just a small piece of what was probably a much larger comet for which we don't have a name.
Right. So to be clear, the parent body idea is a lie. The parent body is simply the largest remaining chunk from the parent body.
Well, in the case of the Taurids, yes.
In the case of all these, 7P Pons Winnicki is still up there. It's a giant object, and it also has a debris field, meaning that is a large chunk left over from an original larger body.
Right.
Yeah, so none of these are the original body.
Right.
Halley's Comet is the largest chunk that we observe in the debris field.
Mm-hmm.
So there was a larger body that had to break up for all of these.
Mm-hmm. Mm-hmm.
And the reason that some of them are unnamed is because they're probably so old of a comet, there is no large piece left.
Right.
Yeah. So that's kind of cool.
Yeah.
What else here? Well, there's also different types of comets and meteor streams. Just like we have 3 different types of comets, which are like periodic, quasi-periodic, and non-periodic, there's also meteor streams that do the same exact thing. And that has to do, and this is great. I can't implore you all enough to go to meteorshowers.org. It's the easiest interactive website. If you've ever been scared to go to one of these 3D interactive websites, this is the easiest user-friendly site. So you can change the speed of the meteor stream up here just by clicking and moving it. And that's because there is a huge variability in the speed of these streams. Take a look at, this is the Eta Aquarids, okay? This is coming up in May. Let's just compare it to the Geminids. Look at the difference. And so there was a comet that was just traveling right here outside of Mars and the sun. How did it get there? What happens is an object comes in and gets captured by our sun. And if it has the right speed, and maybe it gets affected by another planet here, it gets sucked into a tight orbit.
Right.
And look at how dense the debris is in that little field.
Right. Yeah. Super dense. We should probably be glad that our orbit is not crossing this. Well, a little bit.
Yeah, once a year. So, right, you can see it's in an inclined angle.
Yeah.
So the object was from out of our solar system when it came in. It got captured by the sun and then flung around and got captured there.
Yeah.
So it only passes, Earth is the green. So we've got Mercury, Venus, Earth, Mars, and then Jupiter way out here.
Yeah.
And so that is the Geminids. When the Eta Aquarids, let's compare it at the same scale, is a much larger parabolic. Look at this. It goes outside of almost to Pluto.
Yeah.
Look at that.
Yeah. I mean, I feel like that also tells you something about how important the electrical charge of a comet and its debris is, right? That these orbits are retained even as the debris stream over time becomes much more homogeneously distributed, or much more widely distributed, especially in this case with an orbit that large.
Exactly. And take a look at this. The Eta Aquarids and the Perseids are objects that are coming from the same distance because they result in the same size of a trajectory here. So we can see that cometary bodies are coming from different places in space.
Absolutely.
But in groups, like they're the Geminids. That's way different than those last two. Let's take a look at the Taurids. It's the same as the Geminids. Very tight and very close. But it's more planar. See how it's flat almost right there on with the planets?
Can you pull the southern Taurids also? Because they happen at the same time of year. And it's supposedly all part of the same stream. So I'm a little confused about why they're grouped differently. Is there not a...
Yeah, watch this.
Right,
watch
southern.
the Earth. Watch the Earth. You ready?
Yeah.
So we go through right here, the stream, 5, 6 in the summer, right there. And then 9, 10, 11 in the end of October, early November there. So that's the two streams. And the reason we have two is I was trying to show you here. You see it's on the plane of the ecliptic?
Yeah.
Yeah.
Yes.
So that's the most dangerous. Look how wide the field they're showing here is. It's not concentrated on the orbit. It's like a huge field.
Shoot,
and
I heard a
the reason that
number.
is this planet right here. Jupiter has a very slow orbit here. And so every couple years, when it comes over here, it starts to affect these bodies and pulls them towards Jupiter. Which is why this field is very wide and very unpredictable and may be very dangerous.
I heard a figure for a number about how wide the stream is, and I can't remember what it was now, but it's
That's
pretty
crazy
impressive.
just on the simulation.
Yeah.
The width is almost it's bigger than the orbit of Earth, bigger than the orbit of Mars.
Yeah. Can you pull
Crazy.
the southern Taurids?
They aren't on here.
Yes, they are. There are two
right
up
there.
from
Okay.
that one. Yeah.
It doesn't change. It just has a different density.
Yeah. So these are considered two different groups, but part of the same stream. So I'm assuming that all of the Taurids came from a similar large comet body, I would assume that the two groups are a function of some other electrical interaction that kind of like separated things a bit.
Yeah, let's see if this is as planar. Oh, this is completely flat. The other one is slightly inclined.
Yeah.
See how that is completely flat on it?
Yeah.
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 The northern was slightly inclined. So that would mean that during the Younger Dryas event, well, actually, we'll get to the paper. The newest estimate is puts back the parent body for both of these streams to 20,000 years.
I've seen as people hypothesize as old as 40,000.
Yeah, so the
years.
original number was 30 or 40,000, but the most recent idea from two scientists I'll get to puts it at 20,000, which ties in pretty good with the end of the Ice Age and some of the thoughts we had, like maybe some of these, the first breakup, a piece hit the sun, and that outburst allowed for the Bowling Alarod warming. And then pieces hitting the Earth resulted in the Younger Dryas cooling.
Well, that's kind of what I think, and I didn't get too deep into this, but one idea would be that the large comet body, whatever that was, actually entered our solar system somewhere around 30 to 40,000 years ago, but didn't break up until between 15 and 20,000 years ago, which could what's the word I'm looking for? Correspond pretty well with the a big piece, let's say, impacting Earth for the Younger Dryas event.
Exactly, and also create the two Taurid streams. So if the main parent body broke in two, like Biela. What happened with Biela is when they broke apart, one of them assumed a different trajectory.
Eventually.
Yeah. So if the main parent body of the Taurids broke in two, one of the pieces had a slightly different trajectory, and that's why we get the north and south, slightly inclined, the same stream, but in two parts.
I mean, what's weird too is that, by the way, just to back up to this naming thing, is that we have a different name for the part of the Taurid meteor stream that appears in June and July. But it's the same stream, isn't it? What is it? Where is it? I had it written down. Oh, the Beta Taurids and the Zeta Perseids in June and July. But these are the ones that we don't see because they're coming at us from the direction of the sun, so we can't see them.
Yeah, that's not a good... you shouldn't stare at the sun.
No.
Yeah, so let's go down here. The northern Taurids. And here are some parent objects. So the northern Taurids different than the southern Taurids. The southern Taurids are not here.
I thought I just saw them. Scroll down.
Here we go.
Southern
Taurids. Comet 2P Encke. So that is the main piece that broke up from the parent body of the Taurids 20,000 years ago. One big piece was Enki, and it formed the southern Taurid stream. So Enki's been breaking up and shedding debris, and that is the southern Taurids. And the northern Taurids, where are those? I just had them.
It's right underneath the southern.
Look, minor planet 2004 TG. So that's the other piece of the parent body. And here it says it may be a fragment of comet Enki. Well, of course.
Yes. Well, this is interesting. One estimate suggests that the original parent body, not Enki, but the large comet, might have been as large as 100 kilometers wide. And while Enki right now is only like 5 kilometers. So that gives you an idea of how much material is in those debris fields. It's a lot.
Yeah, in Wikipedia, it says Comet Enki and the Taurid complex are remnants of a 40-kilometer class comet. Yeah. But it's all speculation.
Well, I think it has to be very difficult to calculate, because what you actually have to do is you essentially have to take all of the trajectories of all of the debris and kind of backtrack that in order to find an original trajectory and size, which would be very difficult to do. I mean, we have a hard enough time tracking all of the pieces of the Taurid meteor stream right now as it is, so.
Exactly. Now, the bad news is the way that we're recording right now, you're the only mug that's getting recorded.
Oh, dear.
Yeah. So we got to figure that out.
Huh, that's strange.
Yeah.
Isn't it recording the screen itself?
It is, but it only, now with with Skype shrunk down, it only shows one of us in the corner in a box.
Huh.
Yeah.
Weird.
All right, a paper coming out in 2021. So the Taurids have been studied.
Yeah.
And studied indeed. Prior research suggests there is a swarm of large asteroids hidden in the Taurid complex, which is bad news for people on Earth.
I found it funny, actually, that they're referring to these as asteroids, because given that they're in this stream, they're probably, I can't imagine how they wouldn't still be electrically charged. You know, and you and I make the distinction, and this is kind of an electric universe thing, that, you know, essentially an asteroid and a comet are the same thing, but the comet is electrically charged and the asteroid is not. But it also goes back to, there's a really important 1994 paper that was written by Asher, Klube, and Napier and Steele. We've gone over some Klube and Napier papers in the past that really gets into the nitty-gritty of the Taurid meteor stream, and they also refer to some of the bigger chunks in there as asteroids.
You're talking the coherent catastrophism paper.
Yes, this paper. Yeah.
So we could pull
so
that
they
up.
also refer to them as asteroids.
What year was this?
94.
Okay.
So this is kind of pre-electric universe.
Yeah, so what's interesting is they were able to identify 88 large chunks, which means that there are thousands more up there.
Yeah.
Yeah.
Yes.
And so this is a significant meteor stream because there are so many large objects up there. It is on the plane of the ecliptic of planets, which is why we travel through it twice a year. And the stream has two components, one slightly inclined and one flatter. So the interaction between the two, they must cross at the inflection point of where they broke up, which means large objects can collide at these flexure points. It's probably rare, but when they do, that's when an object can be headed our way. And there would be no warning. It would be the flexure points are close to Earth's orbit.
Yeah. Well, and so this is the hypothesis behind Tunguska, was that Tunguska was actually a piece of this stream, the June-July version that we don't see coming. But
right, so it came from the sun,
time-wise.
and no one saw it coming.
Right.
And that's how I think it's going to happen.
Why?
Because on the night side, we can see the objects. We've just recently been able to see the objects before they hit Earth. So a day prior, we see the object, and then it hits. And now we've done like 7 out of the last 7 objects to hit Earth. So With the current technology, we can see the object coming, just not from the sun. That doesn't exist.
Right.
So it's going to come from the sun because we'll never be able to see it coming.
Well, one is just more of a surprise than the other. That's all.
Yeah, because the other, we just know we're going to get hit. We don't have enough time to do anything.
No, exactly.
So every year at the end of October, the event known as the Taurid meteor showers occur, giving those who venture out into dark spaces the opportunity to witness a host of shooting stars. Prior research has shown that they are actually debris left behind from Encke's comet as it passes relatively close to the sun each year. In this new effort, Ferrin and Orofino claim they have found evidence of a swarm of large asteroids hiding in the Taurid complex. They further suggest that the asteroid swarm is part of a debris field left behind by a very large yet unnamed comet, the one that gave birth to the little chunk called Encke's comet. And here they say, while studying the complex, the researchers found 2 asteroids that had not been seen before, and measurements of 2 space rocks showed them to be 200 and 300 meters across. That would be a big boom.
Yeah.
So a 1,000-foot wide rock is called a city ender. So it would take out, 7 square miles of all life.
Well, and the other thing too, right, is that it doesn't necessarily have to directly impact the surface. It can be like a Tunguska event where it explodes in the atmosphere above and creates a lot of destruction below.
Oh, yeah, because if it's this big and it explodes, then you get 1,000 impacts.
Right. So imagine rewinding this 12,000 years ago, and we have a debris stream that is probably has bigger chunks and is more concentrated in particular areas. So if we intersect the stream at a very concentrated area, our chances of having a major impact or set of impacts would be much, much larger. And that may be what happened during the Younger Dryas.
Yeah, I concur.
What was it, like 2 years ago, we did an episode where we reviewed the famous Sweatman and Sitricus paper where they do some archaeoastronomy on Pillar 43 in Enclosure D, which is known as the Vulture?
The Vulture Stone.
The Vulture Stone, thank you. I couldn't think of it. But one of the conclusions that they reach is that the Vulture Stone points to a very specific date in time, 10,950 BC, and that the pillar shows something coming from the area of the Taurids. So the idea being that this particular stone is a recording of an impact from the Taurid meteor stream and a warning about it as well.
Yeah, but they're burying that, and they planted a bunch of trees on top because they're trying to hide that information. Well, the irony of all that is that they've, like I just told you, people claiming that they planted trees to cover up Göbekli Tepe. I just told you last month they cut all those trees down.
Right.
So clearly it's not a conspiracy theory.
Right.
The reality is that there aren't any teams of archaeologists that are available to do all of these digs.
Yeah. And Göbekli Tepe is a huge complex. I mean, what is it, like only like 5 to 10% of Göbekli Tepe has been uncovered so far?
Yes.
And we really need to do that, right? Because from the little that we've seen, it really does appear that Göbekli Tepe is at the very least, recording all of the human observations of our solar system over a long period of time, that it's some kind of like, teaching instrument and perhaps has larger implications than we realize.
Which would make sense if it is, in fact, some type of observatory, cosmological observatory for cosmic catastrophes. The Taurid complex may be the smoking gun. The original parent body, if it was 100 kilometers across, would have been a terrifying sight in the day sky and the night sky if it was a discharging comet. It would have been enormous and terrifying. And it would have gone behind the sun and maybe come out as two terrifying pieces connected, just like Biela. And not only did it almost eliminate all of humanity 12,800 years ago when huge pieces impacted the ice sheet, spraying ice bolides into space, which re-entered and formed the millions of Carolina bays, shaking the earth as a 9 magnitude earthquake for 24 hours. It must have been terrifying. It killed 65% of the megafauna in the Northern Hemisphere.
Yeah. Well, I mean, think about it this way. When we talked about Comet Biela last week, which at the time that it interacted with our atmosphere was fairly broken up. And, you know, it appears that what happened is interacting with our atmosphere created a bunch of spontaneous fires all across the Midwest of the United States. That's a relatively insignificant event. It's not, right? I mean, on the human level, it's huge. But then imagine a comet or two comets that are significantly larger than that, you know, interacting with our surface and our atmosphere and the kind of destruction that could cause. And I said this last week, it's really no surprise that comets were viewed as the harbingers of death, that's this narrative that has sort of perpetuated itself throughout human history. Because look at all of the meteor streams that we interact with on an annual basis. You know, comets entering our solar system is not like an uncommon event. It happens all the time, apparently. And I'm talking about over the course of millions of years. But, you know, even considering the size of the pieces that are left in the Taurid meteor stream compared to potentially the size of the original planet body, you know, let's say 20,000 years ago, at the point at which it started breaking up. I mean, it clearly takes a long time for these comets to break up. But we continue interacting with them for thousands and thousands of years. They just become less and less dangerous over time simply because of the size and the dispersion of all of the debris. You know, but look at all of these streams.
Yeah,
there's
almost 50 that are pretty regular.
Yeah.
Which means that we've had 50 close encounters with civilization-ending objects, and there will be more.
Yes.
The initial impact from the initial body of the Taurids burned almost all of the Northern Hemisphere. So, and then it wasn't over. There are papers, peer-reviewed, and we talked about this, I think, 2-3 years ago, that the same impactors that caused the Younger Dryas came back in and ended the Hopewell civilization in North America. More objects struck and may have ended another civilization. And these are the mound builders, which are other cosmological structures.
Yeah.
So clearly we had our eyes to the sky in antiquity.
Well, and then consider also that in the case of the Taurids, you know, it's like 4 times out of every 6,000 years that we're going to interact with like a high density region of the Taurids. So there's great capacity for catastrophe within that.
Is that in the paper?
That is, I think, from the Coherent Catastrophism paper. It might be from somewhere else. I was kind of reading around a lot today.
Yeah, in the current. So we'll leave you links to all these papers below. If you want to go get them, we repost this on our Rumble channel, Magnetic Reversal News, at 8 p.m. So we're going to be
Mountain Time.
Go ahead.
Mountain time.
8 p.m. Mountain Time, and we'll be live streaming that on Rumble.
Yeah.
The global hazard to civilization from space is by no means only a 20th century problem. Thus, the seminal 1860 British Association debate at Oxford between Wilberforce and Huxley and the others concerning the ultimate fate of our species on this planet was as much an issue of short-termism versus long-termism. What are your thoughts on that?
I don't know what short-termism versus long-termism means.
I would think it would be the difference between uniformitarianism and catastrophism.
Oh, sure, right? Because the coherent catastrophism is just a way of saying we have regular catastrophes on Earth that kind of happen on a schedule. That's the coherent part, right? It's a frequency. Whereas the uniformitarianism is, everything remains the same, except it changes very slowly over time, which clearly is not the case because we have these punctuated incidences of catastrophism that have happened on Earth. We can see the evidence of that. And a meteor stream is a great example of how that would occur, right? If we're crossing the high density regions of the Taurid meteor stream 4 times every 6,000 years, well, there's zero chances of a catastrophe.
Yes, and there have been lots of books that write about catastrophes in our past. Isn't that funny?
Yeah. Well, and there's tons of mythology around that as well. I mean, people have been writing about this for forever, and yet we scientifically pretend that none of that matters, that it's not an indication of anything that's happened in our past. But clearly it is. Again, why do human beings keep saying that comets are the harbingers of death? It's because they are. Because
right,
we've
and I think that they may be able to cause great floods.
Yeah.
And what's interesting is that if we go back to the most recent catastrophe, the Great Flood, which is speculated to have happened 6,000 years ago, prior to that, there is no written record.
Yeah.
It's only after that we get written records, after the catastrophe. Now, luckily, we found a buried encyclopedia in Göbekli Tepe, which will be, I believe, when it's studied long and hard enough, as well as the other sites in the Levant there, that Katahan Tepe and the other Neolithic sites, that they are going to reveal a very sophisticated and advanced society with great knowledge of the cosmos, and they were wiped out. And the people that are doing that are the remnants of probably millions of people that were wiped out during the Younger Dryas catastrophe.
Well, and that's just it, right? If you survived that, of course, you're going to try to record it in some way. You're going to say, this is something that future generations need to know about. And that appears to be what they did. If Göbekli Tepe really is some kind of cosmological observatory that was intentionally buried, and there's good evidence of that, it makes perfect sense. Like, why would you not make your best attempt to record that?
Yeah, and it must tell so many more stories. Because during the Younger Dryas catastrophe and the end of the Ice Age, there were so many Earth changes, right? The technology, the bifacial point technology changed overnight from Clovis to Folsom. That is because there were no more mammoths to hunt, and they were only hunting bison. So they needed to change the technology. The whole Earth changed in an instant. Sea levels came up in a short period of time, hundreds of feet. So you would have inundation of all the places that everyone used to live and hunt. That would be all under the ocean.
Yeah.
It would be mind-boggling.
Yeah.
It would be an act of God. So I wonder if they had that concept and if God was cosmology itself.
Well, I mean, yes, because I think it's Graham Hancock talks about, what is it? It's the myth of the bull getting like getting an arrow in his shoulder and like bleeding from his arrow. This is the shoulder of the bull is right where the Taurids originate from. So again, it's like you've got the myth mixed in with the actual cosmological observations that people are seeing. You know, it's a simple way of telling the next generation about what happens by giving them this story that, you know, a hero hits the bull and then the bull bleeds from the shoulder, and that's the indication of the debris stream coming out of that part of the sky.
Yeah.
You know, and the myth keeps it alive.
That's fascinating.
Story. Yeah.
Now, I did come across a date when we could go into a thicker stream of the Taurids, and I believe it's not till 2300.
I was trying to figure this out too. I didn't get too deep into it. I saw one somewhere. I read that one date would be like around 3000 AD. I didn't come across that date, but I also saw, and I don't remember where this was, that we might enter a at least slightly more dense region in like 2032-ish. Maybe not the densest region.
So that would mean in 2032, we may have a Tunguska event or a Chelyabinsk. Both of those objects are suspected to be Taurus meteoroids.
Yes.
Tauroids.
Or more specifically, as far as the beta Taurids and the zeta Perseids, right? Because it was a June event.
The Chelyabinsk.
The Tunguska event.
Yeah.
Sorry. Yeah. But, still, as time marches on and this debris stream becomes less and less dense, the danger goes down, but still, obviously it takes tens of thousands of years for this to happen. So we're still at risk, and we'll continue to be.
Right, especially if just in the Taurid stream, we have identified 88 gigantic objects, some 200 to 300 meters across.
Yeah.
Those are significant objects. They're so large that they have no chance of burning up and 100% chance of hitting the surface.
Mm-hmm. Mm-hmm.
Yeah, there's a threshold. It's about 50 meters. And there's also a density calculation as far as the potential to burn up completely. And so once you get over 150 feet wide, the likelihood of a piece hitting the surface is very high. And we're talking much larger than that.
Yeah. Yeah.
And what's worse, and this is what's funny, the historical observations we've been talking about for weeks now have shown that these objects break up into two. I just showed you a picture of a comet that broke up into two with the connecting ion tail, right? Biela broke up into two. Why do they break up into two? Take a look at the comet on your screen.
Right.
It's
being
almost
scoured
as
from
if
the middle
the
section.
cosmologists are really dumb.
Yeah. Yeah.
I mean, I can't wrap my head around it.
It is mind-boggling to me because it's not necessarily a matter of stupidity. It's a matter of resistance to new ideas. But even despite however obvious the new ideas are, I mean, all of the electric comet explanations they're perfect and precise, and they provide real explanatory power for comets, asteroids, etc. It's so obvious. The resistance is so strong. And again, I go back to this idea that if you're invested in the current narrative of cosmology, you're resisting it because it threatens your entire career and all of the work that you've done for decades, which is inherently terribly selfish, right? Like, what did I say before? Like, do you want the truth or do you want to save your stupid career? Because in reality, you could have a whole new career that would be absolutely groundbreaking. You could be the next Einstein, right?
Support freedom of speech.
You're only willing to take that chance.
Support freedom of speech. Go to revolution.radio. Watch our show in Studio B every Saturday, noon Mountain Time. And watch the replay on Rumble, Magnetic Reversal News, 8 p.m. Mountain Time.
listening to Revolution Radio.